Hi folks, Mr. Long here. Going to talk to you about solving a problem with the mean value theorem. We're going to start off with a fairly simple one, just a parabola. And remember, we're trying to find the spot on the parabola where the tangent slope, what's the x value of the tangent slope where the x value, where the tangent slope is the same as the secant slope between x equals a and x equals b. And that's what it's all about. Okay, that's what we're doing. And so let's go over this simpler version of the problem. So here we go. Here's the question. Find all values c, means x equals c, that satisfy the conditions of the mean value theorem for f at x equals 7x squared minus x plus 5. Okay, so let's go through this. And I haven't written down the formula for you yet. We'll do that as we go. So let's talk about what are the conditions for the mean value theorem, right? So we need to look and see what are our conditions attached to the mean value theorem. Well, the interval on the closed interval, it needs to be continuous. On the open interval, it needs to be differentiable. So is a parabola always continuous and always differentiable? Because there's our equation right there. Yeah, it definitely is, right? A parabola it's a nice smooth curve with a vertex like so, right? So that's what a parabola looks like, even smoother than that. And it can be differentiated everywhere, and it's continuous everywhere, right? It says here the intervals that we're looking at are -1 and -7. By the way, how did I know to draw it opening up? I just looked at that 7x squared. Okay, 7x squared. So that's all I would do. Initially, I would draw that sketch, right? I would really want to draw that sketch. I think it's important to draw that, just so you have a visual representation. So what's the first thing we need to do? Well, let's get the average slope. What's the slope of the secant? Okay, the slope of the secant. And we know that slope is delta y over, well, that's not a very good delta y and delta x, is it? Delta y over delta x. That's what slope is. So that equals the function evaluated at one interval, at one x value, the function value minus f at a over b minus a, right? That's delta y over delta x. Okay, that's slope, rise over run. That should be b minus a, folks. Okay, so f at b minus f at a, sorry, that's not a very good f at a, f at b minus f at a divided by b minus a. So, and there's b and a right there. So f at 7, so I would plug 7 into this. So plug in 7 for x. So 7 squared is 49 times 7 is 343, or 243, 343 I think, minus 7 plus 5. 320, it's 343. Yeah, it is 343. So 343 minus 7. Anyway, it works out to be, minus -5. So plus 5 again. Anyway, I think you get the idea, right? So we sub in 7, then we sub in -1 and subtract them. That gives us our rise. And then we do b minus a. Again, this is just a slope calculation, right? Average rate of change, secant slope. So we do that, we get 41. So what am I going to do with my diagram now? Well, I'm going to come over to my diagram. I know that the slope was between a and b was, so if I call this a and I call this b, I know that the slope was 41. Okay, the slope was 41. So what I can do is, I've just put a positive slope there, right? So then I've drawn a tangent, or secant rather, and I'm just going to slide the secant down. It has approximately the same slope. Slide it down, slide it down, slide it down. And it looks like eventually we're going to find a tangent slope with the same slope as that secant slope of 41. So how do we find a point in the interval -1, 7 where the derivative is 41? How are we going to do that? Well, I have to figure out f prime of x, that's the tangent slope, set it equal to 41 and solve for x. So what's the derivative of 7x squared? 14x. What's the derivative of -x? -1. Set that equal to 41 and it works out to being x equals 3. So we know then that the value is C, in this case, whoops, wrong one, C equals 3. Okay, so when the x value is 3, the tangent slope is 41. The average slope between -1 and 7 is also 41. Okay, so that point of tangency right there has a slope of 41. All right, so that's the easiest version of the mean value theorem. We'll look at a more challenging one in the next video.